Diolch. Is Morgan an deis bhain seo agus an chur láthir seo dhéanamh. So thanks a million to Breed for inviting us, and we're delighted to be here to present some of our work. It might be a bit too tall for this. Yeah, will it? Okay. Yeah, okay. To present some of the work that we've been doing on developing speech recognition for Irish, and also to speak a little bit about the wealth and the store of Irish language material that's going to become available with the RTÉ digitisation project, and the potential for Irish language speech technology development, but then also for linguistic research as well. So myself and Conor are both from the ABAIR project in the Phonetics and Speech Lab in Trinity. The ABAIR project, ABAIR means to speak. One of the first projects the ABAIR project had was to develop speech synthesis for the Irish language. Speech synthesis being text-to-speech, so synthetic voices. This enabled people maybe who couldn't access information on the internet because they were blind to have things read out for them. So we're really coming from an accessibility and education standpoint. That's kind of our main focus. But more recently, we've been developing speech-to-text. So that's automatic speech recognition for the Irish language. Just a little bit on Irish. It's a low-resource language. It's a minority language. The access to data is quite limited. And as well as that, what compounds that really is that it also has a massive amount of variation. So you have dialects and accents of new speakers. So that obviously makes the process of and the task of speech recognition a lot more difficult. So I'm going to speak a little bit on speech recognition, explain what speech recognition is, how it's kind of viewed classically, and then maybe try to broaden our horizons about when we think about what kind of data we can use in speech recognition, and speak about some of the more recent advances in things like self-supervised learning and semi-supervised learning, which is kind of jargony, but I will explain it, so don't worry. And then I'll I'll pit one of our systems to one of the English systems, so you can really get an understanding of the scale of the difference when we talk about these data sets and the data sets that the English language ASR systems are using. And then the relevance for digital archives, how we view that this technology can be really, really helpful in collecting metadata or even just generating transcripts of the audio material. And then Conor is going to talk about how access to this archival material can be extremely helpful and very interesting for linguists. And then he'll speak a little bit about the challenges to accessing archives, how that can be improved by having transcripts, and why archive holders should care about this kind of technology. And there's a bit of a loop here which kind of shows that speech recognition technologies have been developed with the input of linguists. So there's kind of like a feedback loop here that if we make this data available for linguists, they'll be able to do analysis on it, which will feed back into technology development. And it's that kind of loop that we want to emphasize here. So automatic speech recognition, I'm sure you all know what it is, but I am going to explain it. So it's the process of converting speech into text, very simply. So speech to text is what people call it. It's classically viewed as a supervised learning problem. So this is a bit of a crash course in machine learning, but supervised learning is when you have your input data and you have labels, and you want to learn the mapping between the two. So our input data here would be the acoustic input, the speech, and the output then would be the labels, as in the transcriptions. And all the system is doing is trying to learn the mapping between them, and different systems do that in different ways. But that requires you to have access to speech corpora that have transcriptions, which is obviously not ideal, and access to those is quite limited, particularly in a low-resource context. But the availability of unlabelled corpora, such as what will become available with the RTÉ digitisation project, they're a lot more readily available. And there's been a lot of work in really only the last 4 years, this is very new, on trying to leverage unlabeled data in new ways. So that's kind of what I'm going to be speaking about today. Unlabeled data is just audio without transcriptions, and how we can use that to improve our speech recognition systems. And then just a little, just because I will be talking about different systems, word error rate is what we use to measure performance. So a word error rate is kind of like accuracy -1. So if you had a word error rate of 5, that would mean that your accuracy is 95%, roughly. Okay, more jargon, here we go. So beyond supervised learning. So I said there, supervised learning is when you have the input data, but you also have the labels, so the transcriptions of what you're trying to recognize. But to what extent can unlabeled data be leveraged for speech recognition? So I'm going to speak a little bit about semi-supervised learning or self-training. It's a very intuitive process, really. It's where you start with a seed ASR system, or one that's fairly good that you've trained, and you use that system to transcribe material. So you use that system to transcribe unlabeled material, and then using some sort of heuristic or confidence measure of your results, you can filter out the good from the bad data. And when you know that you have a certain portion of that data that's been transcribed that's good, you can feed that back into your ASR training, thereby iteratively kind of increasing the amount of data that your system has. A recent paper that was speaking about self-training used a 100-hour labeled corpus and a 360-hour unlabeled corpus. Now, they actually do have the transcriptions for this, but they treated it in the experiment as if it was unlabeled. So the seed model had a word error rate of 30%. So this was the model that was just trained on the 100 hours. If we look then to the very, very right, at the oracle, that's the one that was trained with the true transcription. So that's combining the 100 hours and the 360 hours with the true transcriptions. That had a word error rate of 11%. But we can see with the self-training method, where you generate the transcripts automatically, you can recover a lot of that word error rate. So about 54% of the word error rate was recovered. So that shows that even if you don't have the true transcripts of a model, if you start off with a decent seed model, you can still use unlabeled data, generate the transcripts yourselves, generate pseudo-labels is what we call them, and use that to train your system. So that's one of the approaches that's kind of beyond supervised learning. The second one I'll speak about is unsupervised learning or self-supervised learning, which, again, I'm sorry about the jargon, but I deal with these words all day, so they're very clear in my mind. But unsupervised learning or self-supervised learning is really looking at what can we learn from the audio itself. So we're not concerned about the transcripts at this point. We just want to build representations of the audio, highly contextual representations of the audio. And techniques such as these have been used in these large language models that we've heard so much about in recent times, the likes of GPT and the series of GPT. So to explain, I think it's a bit simpler to explain this kind of learning using a language model example, but then I'll explain it with speech as well. So I have two sentences here where there's a gap in the middle of the sentence. And the job of a self-supervised learning task or objective is to try and recover that masked token. So like the first one here, where will we blank today? There's many different options of what that could be, and ones would maybe have more likelihoods than other ones, for example. So the job of self-supervised learning is to try and recover that. The same then for the second example, how many days are in a year? There's a few different options, it's probably there, but there could be other ones as well. So then if we look at the speech signal, I have two representations of a speech signal here. To the left is a spectrogram, and to the right is just a normal speech signal. And you can see that there are masked portions where we've just kind of blanked it out completely. So in the same way, a self-supervised acoustic model tries to recover those masked sections. And this task allows it to build very, very rich in information embeddings or kind of deeper understandings about the audio. And why is this relevant? Why am I talking about this? So a recent paper, really a groundbreaking paper that came out in 2020, was speaking about the WAV-TVEC 2 class of acoustic models. And they achieved a 5% word error rate, so that's 95% accuracy, only using 10 minutes of labeled data. But they pre-trained their model with 53,000 hours of English data. So of course, the data was exposed to a lot of pure audio, but this shows what you can do if you have access to masses of unlabeled data, what you can do with just a small amount of labeled data. So, to pit our current ASR system against English systems, just to give you an idea. So you can try our Irish recognition system online at ABAIR.ie. It's trained with about 216 hours of labeled data, and we evaluated it on 4 hours of carefully read speech. Carefully read speech being different from spontaneous conversational speech. And we have an accuracy of about 11%. Now, Whisper, which was released by OpenAI, the people who released ChatGPT, so they recently brought out this speech recognition model called Whisper, and it's trained on 680,000 hours of data, of which 563,000 hours is English speech. So that's just to give you an idea of the difference in scale. And they use a mix of different methods to actually get this data, and but you can see here that on a similar test set, now this is obviously English data, so it's not really comparable, but on a similar test set, they got an accuracy of close to 90, 97, 93, 98%. And it's really, when you're going towards 100%, that's where like the smaller differences take a lot more energy and effort to actually recover. And actually, I was just reading another paper that came out by Meta or Facebook AI 2 days ago, and they casually mentioned that they use 16 million hours of speech in their data sets. So, you know, it's really unbelievable. The amount of data that they can use. So why is this relevant? So speech recognition systems will improve with more access to data. So currently at ABAIR, we're really trying to investigate these kind of methods and tools that we can use so that when we do get more access to data, we can scale up and improve the performance for Irish. And this is particularly important for low resource languages like Irish, where access to corpora is just limited. More robust systems will generate more reliable transcriptions. So the better our systems are, the more reliable the transcriptions will be. And searchable transcriptions, so converting audio or speech into a searchable format like text, will only just unlock the archives for diverse research. And Conor is going to speak about the relevance of the archive for linguistics, and yeah, so I'll pass over to Conor, my colleague here.
Thanks, Liam. Hello, I'm Conor McCabe. I'm a postdoctoral researcher in ABAIR, so I work with Liam a few desks over from him. Now that he's hopefully primed you to see how linguistic research can be applied in a very useful way for archival management and curation, I'm going to try to slip in with a pitch for why other types of researchers might like access to your data. So if we've proved ourselves useful for you, you can also let people like me in to mess around in the archives and see what might be useful for my own research. So I'm a linguistic researcher by training, as you've now heard a few times. Within that, I focus on sound. And within that, I specialize on Irish, and within that, I specialize on Munster Irish. So I have my own niches within niches. For any of you who have a background in linguistics at all, or any sort of exposure to linguistics, this first slide might be a little bit over boring, but I'm going to go through it anyway. Linguists are for the most part cooperative, although sometimes we're not, but more or less we do what's said on our tin, which is that we study language, so anything involving language, but within that some people don't realize quite how diverse the field is. So there's lots of different subfields of linguistics and lots of different types of research that get carried out by people who call themselves linguists. So as I said, I study sound, so broadly we talk about phonetics, phonology. Phonetics is the sort of physical record of speech. Phonology is the psychological organization of speech and how that varies across languages. You could have people who look at structure in more of a phrasal sense, so syntax, sort of phrase-level structure, morphology, word-level structure. You have issues of meaning, semantics and pragmatics, so meaning without context, or if you like, not entirely without context, but pragmatics be more contextual-based meaning. And then there's loads of hyphenated sort of dash linguistics. So sociolinguistics is one I've given there. That's how language behaves in a social context. Applied linguistics is usually matters like, well, it's very diverse, but language policy, language planning, language practice, language attitudes. So there's a sort of social bent to that as well often. And then also there's different perspectives you can take either generally or within these subfields. So for phonology or morphology or semantics or whatever, you could look at something synchronic, which is to say within a given era, so how people speak Irish now in 2023, or diachronic perspectives, which is how language has changed over time. So comparing different eras, tracking how language has developed, tracking how words develop, tracking how pitch patterns develop, which is what I'm interested in, things like that. So that's synchronic and diachronic. And so with such a diverse field, and language itself is of course very diverse, so it's a diverse field and a diverse object of study, there's lots of different types of data that different types of linguists need, and I've outlined a few of them there on the slide. One is of course speech recordings, so if we could just follow people around and take notes on what they were doing all the time, that'd be great, but it's good to have recordings, and of course you as archivists already know that you have lots of recordings. So if we look at recordings of speech, we can extract lots of different measurements or observations from those, depending on what we're interested in. So for example, in my work, I'd look at acoustic measurements. So I'd look at formant values in hertz and durations in milliseconds and things like that. But there's loads of different types of observations you can take out of those data. You can look at written text as well, either archival in corpora or things that you've collected yourself. And then less relevant for archival purposes are things like speaker judgments, giving people tasks so they have to judge whether something is good language or bad language, basically. Interviews where you get things like attitude, things like this. But the things that we're interested in for archival purposes are speech recordings, so actual speech per se that you can listen to, and written text, so the record of speech. And there's lots and lots of linguistic questions you can answer, or at least attempt to answer or address, maybe more conservatively, using corpora, particularly those speech corpora and written corpora. And here it's also important to make a distinction between naturalistic data and controlled data. So naturalistic, of course, is like natural, so you can have completely natural speech, say people just speaking casually, whether or not they're recorded, and you can have naturalistic speech, which is a broader class, which is to say people speaking as though they're speaking naturally. So say in an interview setting, I can tell people, talk about this topic, and it's not completely natural because I forced them to do it or told them to do it, but it's not entirely controlled either. I haven't given them a sentence to read out. Whereas you could have controlled data like giving people a list of sentences to read out or giving them a list of words to pronounce in a particular way. That's more controlled, and you can do that with varying degrees of experimental stricture on how your data are being collected. And in corpora, what we generally have is naturalistic data, and that's why people tend to be interested in it, including linguistic researchers. And why do we want naturalistic data? Naturalistic data is how people actually speak. So someone like me in an experimental phonetic setting can collect all of the controlled data that I want, but at some point I need to be able to see if what I've extracted as measurements from that experimental data matches what people actually do when they use language. And that's where big, large-scale stores of naturalistic data like corpora are extremely interesting to us. So in the first place, it's important to have access to this, which you as archivists know, and is what's been being discussed quite a lot over the last day and a half. Digital access to these things is great because me sitting at my desk can now access something online as opposed to having to travel to an archive and possibly deal with a sort of unintuitive format for the types of machines that I'm using. So in a broad sense, not terribly surprising, but access to these types of data is a fundamental part of being able to use it for any type of research, mine or otherwise. And it's also important to have metadata. I'll use that in a particular sense for linguistically relevant metadata. Obviously, you all know that metadata can mean loads of different things depending on what exactly you're tagging, what's relevant for your particular archive, what types of recordings you have, etc. For us, generally, what we want to know is who's produced what we're saying, because we're trying to track patterns in language, either over time or within a time or within certain social groups, etc. And we can't really do that if we don't know who's said what we're analyzing, no matter what we're analyzing it for. Generally, what you want at the very least is an age, how old the person was when they said it, where they're from, and maybe what their language background is. But you might also be interested in their employment, how they've moved around in their life, etc. Obviously, you can't always have that in the real world. In a perfect world, we'd have loads of data on absolutely everyone and loads of metadata as well. So we need to have access to the data, and we need to know who's actually produced it. And so when I'm thinking about work on Irish, loads of these things are available for English, but the talk yesterday on the National Corpus of Irish forthcoming is very exciting to see, because this is an example of something that we'll be able to access properly, to have a huge scale of data for research on Irish, for my own work in phonetics, and also for, well, any number of linguistic questions. And so for the remainder of this talk, I'd like to go through two brief examples of corpus research, one on English and one on Irish, and I hope to maybe illustrate why it might be interesting from a sort of societal perspective to have access to the types of information that linguists are trying to produce, and then also I'll try to come back to the useful things like speech recognition at the end. So the first corpus that I'd like to present in a sort of brief passing manner is the Origins of New Zealand English corpus, sometimes abbreviated to ONZE. So this is perhaps most similar to what could be done with the RTÉ Archives once they've been digitized with that ongoing project, and once they let linguists run around and have a good time with it, because the origins of the corpus itself were in broadcast archives. So the corpus itself is composed of at least 3 parts, one of which, the oldest part, was recorded in the 20s and 30s by a mobile unit driving around New Zealand in a little van similar to the one that we saw in a picture yesterday, collecting recordings of people talking about their time in New Zealand, local stories, things like this, if there were immigrants, where they had come from, things of this nature. But the interesting part of the older part of that corpus is that birth years of the people who were recorded went back to the late 1840s, which is when immigration from Europe to New Zealand started. And then the later parts of the corpora, which weren't necessarily collected for broadcast, but were collected for specific linguistic purposes or sociological purposes, various types of research, these had birth years stretching up to the end of the 20th century. So in a sense, you could track the entirety of New Zealand English from literally the point that it started up to the present day. So there's millions of questions you could ask when you have data like that. But among them, you've got papers that have come out about tracking the development of New Zealand's distinctive vowel system, or particular words and how they're used in New Zealand, New Zealanders' own attitudes towards their dialect as opposed to being a sort of dialect of British English that's been transplanted to an island, how that develops over time. You've got loads and loads of questions and really rich data, which just partially by chance has been preserved in a very useful way and then was finally collated and put together for linguistic purposes in this corpus. So you can look at language change, dialect development, attitudes of speakers, all these things. And this is extremely interesting, and I hope in a broad sense it's got a sort of interesting cultural impact factor beyond just linguists who are interested in looking at language because they think it's quite cool. So that's an example of an English-based broadcast corpus, at least partially broadcast corpus, which has now been leveraged for linguistic purposes. Looking at an Irish case, there are sort of smaller corpora of Irish, nothing quite like the scale of the NCI, which is to come, we hope. But in my own work, I've done a little bit of corpus work with the Dugan records, which are held at the Royal Irish Academy. They're named for Wilhelm Dugan, who is a German phonetician invited to come to Ireland in the 1920s to record dialects of Irish for mostly linguistic and heritage purposes. So it's a fairly large corpus, originally made on wax cylinders, now digitized and available freely online, which is great. It was also great during COVID when I was doing my PhD and I couldn't do field work, so this is already available online. And I've got an example there of one of the recordings. This is a farmer from Kerry born in the 1850s and then recorded in 1928. If it plays. Or not. Yeah, so that's Vi Faran agus Vi Bert Vakage. There was a man and he had 2 sons. It's the beginning of the prodigal son. So it's a story retelling. These are all storytellings and retellings. In my own work, what I was looking at doing, this is diachronic work, making a comparison between modern data that I collected in the 2020s with data from 100 years ago collected in the 1920s to see how, particularly prosody, I look at intonation and speech rhythm, seeing how those things changed in this particular subdialect of Irish between 1928 and 2021 at the time. And so I was able to bridge controlled and naturalistic data by using these recorded corpora, which were extremely conservative. There were still monolingual speakers of Irish at the time this was recorded. That doesn't exist anymore, not really. There was much less influence from English at the time. So it was a much more conservative era. And so that was great as a starting point, but having an accessible and searchable corpus of 20th century Irish and then 21st century Irish and the National Corpus of Ireland would be a great way to move forward with that. And this would answer lots of questions about something which in the Irish context is so socially and culturally valuable as a part of our heritage, how Irish has developed, what it looked like 100 years ago when our state was first founded, what does Irish look like now, how is that continuing to develop. And I think that's interesting beyond linguistics. So we can look at ongoing changes in how people speak. And so to that point, I've got a recording from 2021 of the same sentence, the beginning of the same story, by a young woman from Kerry. So the same region, but different gender, different age, very different time. So they obviously sound quite different to each other. Of course, there are personal differences, but if you study this instrumentally, there are also interesting linguistic structural differences between how they're saying the same thing two different ways. Oh, sorry. Oh. Okay, that's the end of those. So why is this relevant, just to wrap up? So in a general sense, of course, there's a public benefit to access to knowledge, which is a very broad and sort of vibe-based thing to say, but I think it's true that the public having access to things which are recorded publicly or broadcast publicly and stored publicly is a good thing, and we should be able to extract that information. And language in particular is so fundamental to how we identify and how we are and how we exist in a society that having access to information, both scientific, linguistic, and then also broader sort of socio-cultural themes is very important. So being able to do this type of research is, I think, useful. Going back to our little feedback loop of how we can make this particularly relevant for archive holders and archive managers, having technical linguistic knowledge and not just model training and not just knowledge of AI and how to develop new speech models, but broad-based scientific linguistic knowledge about how language is structured, that can be useful to feed back into the development of these speech models. And it's not always in immediately obvious ways, which is why basic research in linguistics and other fields is relevant and why it should basically be funded. Is that you don't always know exactly how something is going to be applicable when you do the research, but you can develop applications for it later on. And so this goes for linguistic structure as for anything else. And then also, and I put a little bit of an asterisk next to this so I don't overpromise, when you've got recordings about which you know very little, except for the fact the recording exists, linguistic knowledge can sometimes help to fill in gaps. So we can maybe help to construct or reconstruct missing metadata. Now, we can't exactly tell you who someone is if you've got a shellac disk and you don't know who it was recorded by or who's in it, but we might be able to tell you with a fair degree of accuracy that this has a rough match to other recordings that were made in West Cork in 1930, between 1930 and 1942 or whatever, and you can sort of start filling in those gaps in a certain way, which can be useful, I think. So basically we want these data for our own purposes, for scientific linguistic research, but I think that we can sort of work together and we can help develop better speech technology. The speech technology will then make your corpora more searchable so we can answer more linguistic questions, and it'll go on like that, sort of round and round. So I hope that we've made our case to you, at least in a semi-plausible way. We've got a few references for you there, acknowledgement of our funders, but thanks very much.